Hello, everyone, and welcome to SVGs. Let's talk about them. I don't know what you'll be able to do by the end of this, but something probably. Maybe what you'll be able to do by the end of this lesson is talk about SVGs competently. Let's start there. So, SVG stands for, who can tell me?
It's a scalable vector graphic.
There we go. What's kind of funny about this is we could have just called it a vector because vectors are by definition scalable and they're also by definition graphics. What we mean by scalable vector graphic, we have two ways we can do graphics. We call raster images and vector images. So a raster image is pixels, points on a grid. And so we go, all right, I've got this grid. This one is red, this one is cyan, this one's yellow, this one's red, this one's red, this one's blue, this one's green. This one's transparent, this one's transparent, this one's blue. Points on a grid. That's a raster graphic. Vector graphics, by contrast, are math. They go, all right, I have an arbitrary XY plane here. And I say, all right, at this point, I connect to this point with a line that slopes like that. This connects to a point over here. This connects to a point over here. This connects to a point over here. The area enclosed by this is shaded just such. And that's how we do vector graphics. Why might we do one over the other?
You can resize the vector one easily.
Can't I resize the raster one?
It loses resolution.
No. As I try to blow up a raster image, all I can do is double up on those pixels, right? And so if I zoom in on it, it starts getting blocky. So like this would describe any image. So if I look at this adorable doggo pupper, we can start making them look real fuzzy as we start zooming in. And if you keep going, ultimately you just see these big gross blocks. Womp womp. So by contrast, if I pull up some vector, that does not appear to be a vector. Maybe this? Yeah, that looks like a vector. Ah, it's a P. They made a PNG of the vector though. Maybe it'll still work. Oh yeah, that looks pretty good. It still fucks up a little bit. You can still tell it's a PNG. But that's the general idea, is that we can infinitely zoom in on something. And since we're describing curves, we're describing lines, we're describing shapes, they scale infinitely, up, down, whatever. You make it a postage stamp, you can make it a billboard. The math is the same on it. Cool. Questions so far?
So would pathing work for both of those types, or would it work only with vectoring?
Only with vectoring.
Okay.
Pathing is a vectoring idea. More questions about rasters versus vectors.
Just for clarification, can I, what do you mean by pathing for the vector versus the raster?
This. At this point, draw a straight line to this point, and then draw a straight line to this point, and then draw a curve with the following easing between this point and this point, and then reconnect back to this point. That's a path. Now, we can do stuff that looks pretty neat with just that. For example, like that's a gradient, that blue. It's lighter over here and darker over here. But we can describe that gradient with math. We can say, do a linear gradient from this corner to this corner between this color and this color. And it can do the math to figure that out, regardless of what size it is. So while we can't do photorealism without essentially recreating raster graphics by having every point be separate, we can still do stuff that looks pretty slick with SVGs. Other questions about rasters versus vectors?
Is this mostly going to come up? Is this mostly stuff we're going to be operating on with CSS, or would we need to do some sort of outside?
So these are
program for
just
messing with it?
graphics. You can use them in image tags the same way you use PNGs, JPEGs, whatever. SVG is just another one of those. Some advantages of SVGs. They are scalable, duh. Because if I have an image, there's always this tension with raster images where if they're too small, if I look at them blown up, they look like shit. If they're too big, they take too long to download. Like if I have a giant ass image and I'm on my phone and the image ends up all scrunched up, that doesn't make the download any smaller. I'm still downloading the full resolution image, but I'm only looking at it this big. So there's a way in HTML to specify, all right, based on the resolution of the device, download this image. Because like in a perfect world, it's exactly fit for whatever size our viewport is. If we had to squish it down at all, well, we're wasting network. If it's too little, then we're sacrificing resolution. So the SVG, it's always scalable to exactly what we want it to be. Also, since they're just instructions, it ends up being significantly less data than having every single pixel in an image. So they're also tiny. And then lastly, since they're just instructions, it's not binary, they're also pretty easy to edit. Some advantages to SVGs. Questions?
In the instructions for a vector, does it have, I mean, it has to define an origin, right? Like, because if you're telling it go this far in a straight line to this point, one of those points is your home point, right?
Yeah.
This is where you start. Yeah.
Well, kind of. You do have to declare a canvas, and you need to declare units for the canvas. So you could say that this is 5 ticks this way and 4 ticks this way. And then all of your coordinates are just relative to that canvas that you described. But like, it's arbitrary. They're relative units. Other questions about vectors? Cool. Super common use case for vectors, and like probably where I see them the most is in icon libraries. Icons are like perfect candidate for vector graphics. So if let me see if I have any on my page. I think I do. Womp womp. I have some that aren't showing up. Well, that makes me sad. There they are. I'm pretty sure these are vectors. Let's take a look. They're wrapped in that I tag. They brought it in as a font. That's why. SVG icon library. Bootstraps. Let's take a look at theirs. Perfect. Check it out. All of these. This is it. There's no pointer to like another file. It's literally just these instructions. And when I mentioned that they're like relatively easy to edit, we can like rewriting a path by hand is kind of a nightmare, but let's see if we can change the color of it maybe. Fill, how about red? Oops, that was white. F000. Cool, now it's a red alarm clock. So like doing some of that kind of light editing with an SVG, not so bad. Because if we take an SVG, see if I can find a sample. God, that's a ping too. Also a ping. Come on, Google. Help a brother out. There we go. So if we take this one and download it. Shoot. Won't let me download it either. Well, I can just take a look at the source because it's just code. If I copy this and go to something, I do touch something dot SVG and just paste all that in there and then light server it up. See, it was something dot SVG. Pretty cool. And how big is it? 3.5K. Not bad. That's it. That's the whole thing.
Could you explain the view box a little bit?
Sure. So this is kind of like what Brian was asking about with origins. If you think of this vector grid here, what we've said is that this is the part that we can see. You can also say that like the total coordinate plane is this big, but everything that I'm writing in here should only be this. That's technically what a view box is. But I think if that's the only thing that you set, then it'll make like the total canvas and the part that you're actually working with the same size. And then this last part here is where we're translating these math instructions to like an actual physical amount. So like if I did, say I went nuts and I just made these like 8,000 by 8,000, all the coordinates stay the same. Except now it's huge, but no loss of resolution. Likewise, if I make it teeny tiny, scales down pretty well too. Other questions?
What are all the tags on there? That M, L, and Z.
Sure.
Is that
So so this is XML. XML is a superset of HTML, which means you basically already know it. So XML describes like closing and opening and closing tags and attributes and just like the syntax of anything that does that, of which HTML is one variety, SVG is another. And then like XML was also used as like the primary data format before JSON took off. Because like you can just describe arbitrary data this way. But the general shape of it is you have tags that open and close. You can have single-ended tags, and you can have attributes that can have values. That's it. That's XML in a nutshell. HTML is like this specific set of 200 tags, and they have these legal attributes and whatever else. SVG has the same. So like a G is a group, and Gs accept transforms. A path is a kind of XML tag. It is allowed to have a D attribute, and the D is allowed to have any string that is formatted the following way. Now, in particular, a paths D path commands. Let's see, there we are. There you go. Move to, line to. So this is like go somewhere and then draw a line in between them, whereas this just skips. C and S are curves. Q and T are a different kind of curve. A is a different kind of curve. And Z will just close off to wherever you began. And then the things that follow them are coordinates. Move to this X coordinate and this Y coordinate within this box. And notice they all end with Z. They close it out. And then within those, we can apply these fills. These could be solid colors. These can be gradients. They can be whatever. A stroke. In design terms, a stroke is a line. And so like this one here will be a line, a black line that goes around something that's filled in with white. More questions? Cool. That's kind of it. There really isn't a whole lot to this. That's what a vector is. That's what they look like. You use them the same way you would use a JPEG or a PNG, just as a source for an image or something like that. They're tiny. They're editable. They get real big and real small. It's an alternative to rasters. All you need to know about SVGs.
You won't, like, you wouldn't really like hand code an SVG. You would draw it with like Photoshop or something or Illustrator, and then it would turn into, okay.
I've never met somebody who hand codes their SVGs. But like I hand edit SVGs all the time, usually to change a stroke color or a fill color or something like that. Anything else you want to know about them?
I mean, I have something I was kind of working on and I can't get it to show up properly. So I don't
Okay.
know if this is like an after class thing or.
Screen share. Let's take a look at it.
So the problem I'm having is the height and width are having to be really big to get it to actually show up. So basically it animates and it draws in the path of these words.
Okay.
So like when I'm looking here, I can see the SVG and the path is down there.
Uh-huh.
So when I make this smaller, it's no longer wanting to show up because it's saying the path is down there. So I'm assuming I can't view it because the thing I'm trying to view is outside of the SVG.
Yes. In part because you're doing this to the SVG itself. You should throw that SVG in a file and then do this off of an image that's using the SVG.
Okay.
Because all these changes you're making are to the actual canvas. You don't want to do that.
Okay. Cool. Thanks.
That should solve your problem. And yeah, for particularly what you were going for, that's actually a pretty good use case for like absolute positioning or fixed positioning or something like that. And then just have the thing you're doing be that image. But then you can separate the concerns from like, what is this graphic versus how is it being used in my page?
Okay. Thanks.
Other questions? Cool. Short and simple. See y'all at Sandown.